Go ahead.
All right, so last session we had class, we talked about the energy levels in an atom, and we talked about how the further it gets out, the more electrons it can hold. So we're going to dive just a little bit deeper into that by electron configuration. Electron configuration is basically an address where you can find any element on the periodic table. And this is what the simplest one looks like. Can anyone tell me what that element is?
IS?
I mean, how about that? Is that better?
Oh, 1S.
1s, and that's a subscript 1, 2, so we'll do that. That is the simplest electron configuration right there. Yes?
What's the S stand for?
It's just the first sub-level category.
Oh, okay.
We'll get into that. Keep that thought though. Okay, so the farther an energy level is from the nucleus, the more electrons it can hold. That's correct. But it gets deeper because within each energy level, there are sublevels that contain separate orbitals that can hold only so many electrons. So the first sublevel only has, the first energy level, only has one sublevel because of how close it is to the nucleus. So what that is, basically, is a hydrogen atom and a helium atom. So this right here, that's hydrogen. And that's because it looks like this. And it has one electron. One electron, one proton. The second level, the second energy level, has two sublevels. The third energy level has three sublevels. The fourth has four sublevels. And it goes on and on as long as there can be elements discovered. The first energy level has one sublevel. That sublevel is called 1s. The second energy level has two sublevels. These are labeled as 2s and 2p. So right here you see the 1 has the 1 sublevel. The 2 has the 2 sublevels. 3 sublevels. 4 sublevels. If there was 5, it would have 5. And if there was 6, it would have 6. 7, 7. The letters in the sublevels go S, P, D, and F. And that's as far as we're going to go today.
I was working.
Huh? What was that?
Nothing.
Nothing. Okay. So each sublevel can contain a certain amount of orbitals. And so what all an orbital is the path an object is following while it is in orbit around something. So the center of an atom weighs more than the electrons, so the electrons will orbit it just like how the moon orbits the Earth. And all an orbital is this line right here. The path that an electron will follow. And for some reason, electrons like to pair up on orbitals. And every orbital can only hold 2 electrons.
Is that for every element?
Every element, every orbital can only hold 2 electrons, but different sublevels have different amounts of orbitals.
Okay.
So the S sublevel, the simplest one, has one orbital, and each orbital can hold 2 electrons. And so if we put another electron on that atom right there, what do you guys think it'd be?
Hydrogen?
No, that is hydrogen. What comes after hydrogen?
Helium.
Helium. There you go. Very good. So the second orbital, or energy level, here we have the center of the atom. We have our first energy level. It gets filled up with 2 electrons because it has one orbital. Then our second energy level, right there, oh, that's a bad line. There we go. This is our second energy level, right here. That's just one of the orbitals. The second energy level, that's what we know from the last lesson. How much electrons can the second energy level hold? Anybody remember?
4?
Close. Double it.
8.
8. There you go. 8. So if the second energy level can hold 8 electrons, how many orbitals does it have?
8.
No?
4.
4. Very good. So not all orbitals look like this. A simple diagram would look like this. And the lines are so close together because this is the second energy level right here, and this is the first one. But it doesn't actually happen like that because, as we know, that orbitals can only hold 2 electrons. So what it would look like is these orbitals are going around the atom like this. And each orbital holds 2 electrons. So, if 1s, the simplest sublevel, then the second following that would be 1s2, helium. After that, we have to go from 1s1 to 1s2, and because it can only hold 2 electrons, we have to move on to 2s. 2s, so right here, let's say that there's an electron here, an electron here, an electron here, electron here, electron here, electron here. So, can anybody tell me how many electrons that is?
10.
10?
Yep. Oh wait, 11.
No, you're right, it's 10. It's 10. So, right here we got our first sublevel. Oh, that makes it 11. We got our first sublevel right there, first sublevel. And here we have our second sublevel. It is both filled with 2 electrons, so it gets 2. Following the S, we dive into the P, and because it has 3 sublevels, we know that it can hold 6. And that is the electron configuration for this element right here. Does anybody know which one that is? No? All right, that's neon, because it's got full 10 in there. So that's neon right there. Beryllium has 4 electrons. What do you guys think its electron configuration would look like?
2 rings.
No, the electron configuration is just the writing.
So, wait.
So if there's 4 electrons in it,
It'd be 1s, 2s2.
you betcha. Just like that. That'd be beryllium right there.
Mr. Schulte.
You betcha.
So what's the electron cloud in our textbook supposed to be?
The electron cloud.
Yeah.
So all the electron cloud is the area where all the orbitals are.
Okay.
It's not, it's like the cloud, like, it's not like really there.
Okay.
It's just the area. So I'm not going to be able to draw any more than that because it'd get too crazy and we wouldn't be able to see any lines. But, so we know that the first sublevel S holds 2 electrons. We know that the second sublevel P can hold 6 electrons. And we know that and now onto the next sublevel D, this sublevel has 5 orbitals, and that means that it can hold up to 10 electrons. The 4th energy level has 4 sublevels. And so if the first sublevel goes 1, the second goes 3, this one goes 10. Oh no, that's 5, excuse me, 10 electrons. And if this one, shoot. So if there's, that's bad. If there's 5 here, so 1, 3, 5, what would this one be?
10.
No?
8.
Closer.
9.
Farther?
7.
7. There you go. So the trickiest part about electron configuration is when you're writing it, you have to follow the order of the periodic table. And so the farther you go, filling up space in each electron, the farther you make it down the periodic table. And so we got 1s, 2s, 2p. What do you think comes after that?
2F,
2f? No. 2 only has 2 sublevels.
3P,
First one.
3S,
3s. There you go. 3s. And if that one gets filled, then what?
3P,
3p. Very good. Now, what do you think happens if this one gets filled? What's the third sublevel
4s?
for 3?
oh wait, 3F,
3d.
3D.
4f is 4, but you're right though. It's 4s because on the periodic table it would be going in order. And if you go 3d here and fill up all these electrons, then you're going to have a completely messed up element.
Is that where the 3D movie come from?
I don't believe so. You're right though, it would go 4s, that fills up, then what do you think?
4P,
What are we missing? Ethan,
3D.
3D, very good. So here, let me show you guys a picture of the periodic table. Ah, beautiful. Okay, so we got 1s, both filled, 2s, these two right here, 2p. How many is this? 1, 2, 3, 4, 5,
6.
6. What do you think that is? What do you think this section right here is? Because it has 6. What do you think?
He knows it.
What do you think? Come on, come on. Don't be shy. So here, you got 1, 1s1, 1s2, 2s1, 2s2.
3S.
No. What comes after 2s?
2P.
2p. 2p, 1 through 6. Then it goes 3s, 3p, 4s. What are these ones?
3D.
3d. Very good. Then it go 3p all the way down to 4. We don't really need to worry about this because down here is where it would go into 7 orbitals, and that's just chaotic.
Another radioactive stuff.
Time.
That's perfect. I'm gonna